All right, so rational expressions and functions. We've done stuff with rational expressions. We just got done doing a whole bunch of factoring polynomials a couple weeks ago. All right, that was right before we got to the PSSA prep and that kind of stuff. So it should be fairly recent in your mind. And a rational expression is just going to be it's not going to have an equal sign. It's just going to have x's, x squared, x, something like that. Mostly a polynomial form. All right, so we want to simplify rational expressions now, especially ones that look like a fraction. Don't freak out. These are not like true fractions. All right, this is a pretty simple concept, I think. All right, so simplifying rational expressions. Here's what you want to do. First off, a rational expression is an expression in the form polynomial over a polynomial. And then to simplify, you want to factor the top, factor the bottom, cancel out common factors, and simplify anything that remains. Okay, so just whenever you start, get it, say, can I factor it? If you can factor it, factor it. If you can't factor it, cancel stuff out. If you can factor it, go ahead and factor it, then cancel stuff out. Because remember, everything has to be written in multiplication for you to be able to cancel it. We good? Good? All right, we'll start with a really simple one to start with. If I have this, 21, we go 21x squared over 7x squared. Now, all right, so first off, is there anything there that I can factor? Well, it's just one term over one term, right? So there's really nothing to factor. Now, is everything multiplication on top and everything multiplication on the bottom? Yeah, on top we have 21 times x squared. On the bottom we have 7 times x squared. So we're in good shape there. We can go ahead and cancel now, can't we? X squared, they cancel because you have one on top, one on the bottom. And what's 21 divided by 7? 3. So that's really nothing new on that one, is there? Okay, there's nothing really changes. Here's where it's going to change a little bit. If I have this now, x minus 1 over 5x minus 5. So this is a little bit different. Now I have something other than multiplication going on, don't I? And I know someone's sitting there going, oh, he can cancel out the x's. Can I? I cannot cancel out the x's as it sits. So that takes us to our factor the top, factor the bottom. Can I factor an x minus 1? There's nothing I can do with that. But what can I factor the bottom? Yeah, I can take a 5 out, right? Factor a 5 out, and I'm left with x minus 1. Now, is the bottom is multiplication? And up top, doesn't that look the same as what I have on the bottom? Cancel, cancel. What's left then? 1/5. It's not too bad, is it? You live with that? Okay, you guys try these two. 18x squared over 4x plus 8. And 2n minus 3 over 6n minus 9. Try those two guys. Both of these factor at the top, factor at the bottom if you can, and then cancel stuff.
You can't
more usable. When you see that on the bottom, I'm like, all right, that's probably a good idea what I'm going to cancel out. So can I factor that top to make it look like that? All right, still with me so far? It's not horrible, right? All right, let's step it up just a little bit. What happens now if I have a trinomial? Let's go 2x minus 8 over x squared minus 2x minus 8. Okay, this takes us back to factoring on the bottom there, doesn't it? Because we have something in that form, ax squared plus bx plus c, right? So the top factor is easy. What can I factor out of the top? 2. Okay, so factor out of 2, I'm left with what on the inside? X minus 4. Okay, that's no problem. Now the bottom is back to our factoring days. When we factor the bottom, we have the leading term of an a that is 1. So this is the easy type for us. We need two numbers that multiply to get negative 8, add to get negative 2. What do you think? Negative 4 and positive 2? Yeah. X minus 4, x plus 2. That's what that bottom would factor to. X squared minus 2x minus 8 factors x minus 4. Take your c term, which is negative 8. It factors that. 1 and 8, 2 and 4. Now it's negative, so you have to do 1 and 8 and 2 and 4. Add them up. Negative 7, or that's just regular 7. Positive 7, negative 7, positive 2, negative 2. We were looking for negative 2, so that's our middle number. Okay? So we factored that guy. We got it to factored form now. Does anything cancel out? X minus 4, gone. Leaving me with 2 over x plus 2. Boom. Questions on that one? You guys try this guy. We cannot because that's a plus on the bottom. If it's 2 times x, we could. Or if it looked exactly the same, we could. All right, so a squared minus 3a plus 2 over 3a minus 3. Simplify that guy. Yep. Multiply to get 2, add to get negative 3. I mean, what are your only factors of 2? 1 and 2, right? And it's a minus plus, so therefore both your answers have to be negatives. Bless you. All right, so the top factors as a polynomial, what does it factor to? Two numbers that multiply to get positive 2, add to get negative 3. Negative 1, negative 2. A minus 1, A minus 2. Can I factor the bottom? Yeah, what can I factor out? 3, leaving me with A minus 1. Do I have anything in common? Yep, A minus 1 is gone. leaving me with a minus 2 over 3. How many people got that one? All right, not too bad, not too bad. Let's do one with our a term not equal to 1. Yep. So I'm sure you probably are going, oh crap, I don't know how to do that one now. All right. It's a z. 2z squared. Yep. All right, so let's just remember how we did these ones where a was not 1. Okay, you had to come off the side, you had to find AC. AC is 12, right? We need two factors of 12, the two multiples that add to 12 or multiply to 12 and add to 7, right? So we got 1 and 12, 2 and 6, 3 and 4. This one here is going to be our winner, isn't it? Now, I'm just looking at the bottom. Okay. So 2 is A, 6 is C. So AC is 12. I'm factoring the bottom. So at the top, you don't have to do anything really for it to factor. All right, so then I have this. Then we did our factor by grouping. We had to replace 2z squared plus 3z plus 4z plus 6. Okay, we replaced our 7z term with these two here, and we split it. Can I factor out anything out of the first part? Well, I can factor out a z, leaving me with 2z plus 3. Second side, I can factor out a, what the heck is this? Is that 6? I can factor out a 2, leave me with 2z plus 3. All right? So then you have your common one, which is 2z plus 3, your leftovers, z plus 2. That's how you do one where your a term is not 1. Okay? So the bottom factor is 2z plus 3, z plus 2. The top, what can I factor out of the top? How about 6? Factor out of 6, leaving me with z plus 2. Now what happened? Boom, boom. Left with 6 over 2z plus 3. Questions on that one? Okay, last one for this section. X squared minus x minus 6 over x squared plus 5x plus 6. Take a minute and try that guy. Okay. 16. It to be 16. Okay, so multiplying and dividing rational expressions. The nice part is everything is already talking about multiplication, right? When we factor something, we turn maybe an addition or subtraction into multiplication. So nothing really changes here. All that's going to happen here now is you're going to have two fractions. All right? So you're going to have two fractions kind of written side by side. So this is what you need to do for multiplying and dividing. Start with multiplication. Okay, how to multiply rational expressions. First thing, you want to write the expression as one big fraction. Fact to the top, fact to the bottom. Cancel common factors. Simplify what remains. Actually, I want to put this step first. You can just put them all the way out. All right, so let's factor it first, then write it as one big fraction. Then we'll cancel common factors, simplify what remains. Okay, so fact to the tops, fact to the bottoms. Write as a big fraction, cancel common factors, and simplify what remains. Give you a second to write that down. Now, not every single one of those are you going to be able to factor first, but that's one thing you want to check for sure. Okay, we ready? You good? Okay. So, start with a really, really simple one that we only have to factor. 6 over a squared times negative 2 over a to the third. Is there anything I can factor there? I mean, they're all single terms, so you can't really factor if they're single terms, can you? All right, so then back to rules of multiplication of fractions. Multiply the tops, multiply the bottoms. So what's 6 times negative 2? Negative 12. A squared times a to the third is a to the fifth. Is there anything to simplify? No, done. Okay, that's pretty simple, right? Okay, that was the easy one. Let's look at the next one here. Let's go x minus 7 over x times x minus 5 over x plus 3. And here's one thing, a mistake a lot of people make is they try to go ahead and like distribute those or FOIL those. So we can't factor any of the 4, right?
Why can't you just cancel it?
Because there's still addition and subtraction in there. It's not multiplication. Now, is there anything I can factor in any of those 4 spots? No. So just go ahead and write it like this now. X minus 7, x minus 5 over x times x plus 3. Now, that puts that into a form that we can factor this, right? Is there anything, or the form that we can cancel? Is there anything to cancel? No, there's nothing in common on top and the bottom. So you just let it. You're done. That's all you gotta do. Okay? Do one more of these easy types, and we'll step it up a little bit. X over x minus 2 times x minus 2 over x plus 3. Now here, 4 spots. Is there anything to factor? No, there's nothing to factor. Nothing to factor at all. So, write as one big fraction. X minus 2 over x minus 2 x plus 3. Is there anything I can cancel here?
Yeah.
Yeah. X minus 2. Gone. X over x plus 3. Question. You wait till the bell. Let's go on the walk. Okay. Questions on that one? All right. Now, let's do one where you got a factor. Let's go. X plus 5 over 7x minus 21 times 14x over x squared plus 3x minus 10. We didn't do anything yet. I just wrote the problem. Take a walk. We'll pick it up right there when you get back. Now, on this one, factor everywhere we can. So, can I factor in x plus 5? I cannot. Can I factor a 7x minus 21? Yeah. What can I factor out? 7. Leave me with x minus 3. Okay. Can I factor a 14x? No. Can I factor x squared plus 3x minus 10? Yes. What's it going to factor to? Okay, so x, it's going to be minus 2 and x plus 5. So now I have everything factors, right as a giant fraction. So on top, I'm going to put this in parentheses. So I'm going to put 14x here times x plus 5. All I did was just change the order. I like anything that's not parentheses, I like it to be on the left. Okay? Second one, I have the 7, x minus 3, x minus 2, x plus 5. Okay, all I did was just take everything on top and write it out, everything on the bottom and write it out. Okay, is there any parentheses I can cancel first? That's the easiest one. X plus 5, that's gone. Okay, now the other parentheses are staying, aren't they? Now I'm going to look at the thing on the left. I got 14x and a 7. Can I cancel there? Yeah, I take a 7 out, so that makes that a 2. So on top I have 2x is the only thing that's left, right? On the bottom I have x minus 3, x minus 2. How's that feel? Okay, I'll give you guys one to try here. I want you guys to try this guy. 3x squared over x plus 2 times x squared plus 3x minus 2 over x. Try that guy.
word that does not like to be called. I don't even have a name. Did they say your first name?
Oh, yeah.
How did you hear it?
Russell, out.
I didn't know his first name. I said it too. Good job. Good job. That's my first one.
She was thrown out one other day. She had to sit in the hallway, remember? Okay. So, make sure it's not muted. There we go. All right, so the top, I have that 3x squared. That's fine. Can I factor the top right? Yeah, what's it factor to? X plus 2, x plus 1. Now, x plus 2 is gone. What else can I cancel? Cancel an x, can't I? I have an x out front. Cancel this x out, and I'll take away the squared. So on top I have 3x times x plus 1. Is there anything left on the bottom? No. So it would be over 1. Do I even have to write that? Nope, I'm done. Questions there? Okay, home stretch. Home stretch.
No. Oh my God, is that another thing with more notes?
Yep. So this is division. Now, here, I'm gonna make it easy on you, okay? So we'll move this up again. And all you have to do is reciprocate the second term, and then everything else is the same as multiplication. Only thing that changes. Remember, division, if you divide by a fraction, if I have 1/2 divided by 3/4, we guys all did that, what, keep it, switch it, flip it, or whatever, right? So keep it, switch the sign, flip it. So all I did was reciprocate the second term, right? Yeah, so all I did was reciprocate the second term. That's the same thing for these. Take the second one, flip it, change it to multiplication. So then nothing changes from what we just did in the last part of the lesson. Okay, switch the second, flip the second one, factor everything, write as a giant fraction, and then cancel. All right. So reciprocate the second term, and then same as addition. Or not addition, multiplication. Really, if you write that first line, you're good then. Okay, 'cause everything else is exactly the same. All right, reciprocate the second term. Now it's multiplication. So you've been saving it up, I guess, huh? What I have most times is called selective hearing. I choose to ignore most of what you guys say. I hear way more than I ever wanted to hear. I can promise you that.
When you stop?
I like the part at the end.
No.
Yeah, we can adopt that as normal. All right, so here we go. 3 prob. Shouldn't have got thrown out. All right. If we have x squared minus 25, 4x plus 28, divided by x minus 5 over x squared plus 9x plus 14. We just went big for these. Okay? We just went big. I mean, there's no screwing around with the simple problems. We just went big on this. All right, so what we want to do first is we want to flip the second one. Okay? So I'm going to rewrite this as x squared minus 25 over 4x plus 28 times x squared plus 9x plus 14 over x minus 5. Okay? So now all I did was take the second one, flip it to get to there. Now it's a multiplication problem. Yes. There is no subtraction sign. No. Okay, you flip it and write it exactly the same way. Now, it looks exactly like the ones we just did before, right? Factor everywhere we can. So, top left, x squared minus 25, is that factor? Yeah, that's the difference of two squares, isn't it? So, this is x squared. This is 5 squared. So, it'll be x minus 5, x plus 5. Okay, the bottom, 4x plus 28, can I factor that? Yeah, I can bring a what out? 4, leave me with x plus 7. Good. Top right, x squared plus 9x plus 14. Is that factor? What's it factor to? 7 and 2. X plus 7. X plus 2. Bottom right, nothing I can do there. X minus 5. Now, if you see, I already put it in a giant fraction form, right? Now's the fun part. Here we go. X minus 5. X plus 7. What are we left with? X plus 5. X plus 2 over 4. Done. Okay. Now, the fun part is I did this with my college algebra trade class later in the year. It was like second lesson of the year. You know, we got to the point, and I was like, "Yeah, when you do this, you got to go the whole way through." So then the day of the test, it's all quiet in the room, and Avery Taylor's over here. She sits right where you do. So it's like dead silent. All of a sudden, I hear, I'm like, "Oh yeah, someone's canceling, right? I can feel it." All right, last one of the day. Here we go. Last one. 4x plus 8 over 6x minus 10 divided by x squared plus 6x plus 8 over 9x minus 15. All right, so we're going to flip that second one as we go. All right. All right. Now, what I like to do, instead of rewriting it, I like to factor it and then just place it, if you're all right with that. Okay, so this one here is going to be flipped. So I'm going to go ahead, make my giant fraction. Okay, top left, 4x plus 8. Is there anything I can factor out? Bring out 4, leave me with x plus 2. Bottom left, anything I can factor out? 2, leave me with 3x minus 5, right? Now, if I'm flipping the second part, I'm gonna factor the 9x minus 15. Can I factor that? What is it? Bring a 3 out. 3x minus 5, because I gotta flip it. I then top right, I have what? 2 and 4. X plus 4, x plus 2. You all right with that? This is flipped. Okay, I just took away this step right here. Okay, I saved myself a step. If you need to put that step in there, by all means, do it. Okay. So let's cancel. X plus 2. 3x minus 5. All right. I got a 4 and a 2. I can cancel that and make this a 2. Anything else to cancel? No. On top, then I have a 6. On the bottom, I'm left with x plus 4. Man, that was satisfying there. To go from this to this, oh, that feels good. Questions? Anybody?